Welcome! This is Electrical and Firmware Training Week 0. This is our first week, so if you are interested in joining this training, then you're in the right place. Just note that this is the same presentation that was given Monday, so each week we give two sessions of the same presentation, so if you're here on Monday, you don't really have to be here unless you wanted to get it again, but yeah. So welcome. So first, we're just going to introduce who we are. There's a lot of us, and so you'll probably have seen them in your meetings on Teams or on Slack. So just introduction if you don't already know some of us. So fourth years, Colin, you can introduce yourself.
Hello, I'm Colin. I'm RoboCup CS, that fourth year track. Yeah, RoboCup is pretty fun. Is there anything else I'm supposed to introduce?
No.
Okay, cool.
Joe.
Hi, I'm Joe. I'm fifth year electrical engineering major. I've been helping out with robo racing for most of those years. Former president, former electrical training lead, former a lot of stuff. So.
Yeah. And then people who aren't here today is Juan. He is Robo Wrestling electrical lead, and he's been working on Robo Wrestling for a long time now, and he's a double E. There's Logan, who is also on Robo Wrestling, and he's software lead, and he's a CS major, and Varun, who is on BattleBots, and he's been on Robo Racing in the past. So third years, there's Arvind, who is on RoboCup Electrical and a Compy in a third year as well. And he is the training lead for Firmware, and he was the one who gave the presentation on Monday. There's Arthur, who's also on RoboCup Electrical and the team lead and is also Compy. Then there's me, Asha. I'm also on RoboCup Electrical. We're all on RoboCup Electrical, really. Also Compy and electrical training lead. And in the past, I was on RoboNav Electrical and Marine.
Hi, I'm Marine. I'm on RoboCup as well. I'm currently the RoboCup PM, EE major, and previously RoboCup electrical lead. RoboCup has a lot of third years. I just realized.
Indeed, we do. We have a fun time.
Oh, Stella, you managed to join. Great.
Oh. Nice. Second years. So we have Andrew, who is not here. He was on Monday, but he is the Robo Racing electrical lead this year, and he's a Compy. There's Eugene, who is on RoboNav, and also Compy. Manas, who's on Robo Wrestling electrical, I believe. And Stella, introduce yourself.
Hello, I'm Stella. I'm a second year, and I'm in RoboCup in the electrical sub-team.
Nice. And Devon?
Hi, my name's Devon. I'm also in RoboCup Electrical.
Yay, so that's pretty much all of us. That was a lot of names, but hopefully you get to know some of us, like either through team meetings or trainings. So with that, we sort of want to address like what are the differences between all the disciplines. So you've definitely heard of like electrical, firmware, and like software right now, and you might be wondering like what are the differences? Am I even in the right one? So we're going to try to go through that, and hopefully if you have any concerns or questions about that specific topic, this might help answer those things. So electrical. So what we do on our teams is mainly developing PCBs, so printed circuit boards. And this is mainly to integrate components that are on our robots, like various sensors we use, motors, and then basically assemble that hardware and test it. And we're also focused on system design. So a lot of these robots have multiple systems, like to control motors, to like integrate safety things. So a lot of the design, there's a lot of design aspect in that. And so electrical training is supposed to help you learn those skills. And so what do we cover with that? So that means covering today, electrical components, and some common circuits. Prototyping, which is mainly with like testing out like mock-up circuits and using like breadboards and Arduinos, which will be in later weeks. Then we have what I said earlier, printed circuit board design using Eagle, which is a CAD software that we use and will teach in electrical training. And then later we're going to do debugging circuits because we do that a lot because mainly most of the times our circuits don't work on the first time. And then in the end, we're going to talk about design choices for electrical systems because after you learn all this information, you might be wondering, how do I get started on this project, or I have this problem, and how do I even start designing a circuit? And hopefully that'll help you think about those things. And so now with firmware, this is a new training because we realized that we need to address people getting more knowledge on this topic. So what people who work on firmware do in RoboJackets, it's mainly writing code that runs on PCBs. So basically writing lower level functionality for software that runs like directly on some of the hardware we create. So what you learn in firmware training for that, the first 2 weeks are the same. You'll learn today about electrical components, and you're also going to learn about prototyping. There's a split that happens in the middle, which I'll explain a little bit later in the presentation, but that's mainly microcontroller programming. So we're going to be working a lot with Arduinos if you're familiar with that. If not, it's okay. And what communication protocols are, so how like devices can communicate with each other. And then in the end, we're going to cover the same topics electrical training does with debugging circuits, because there is like software elements to that. And of course, design choices for electrical systems. And I know especially a lot of people are wondering, oh, should I join electrical or software? So to explain what software does and how it's different from sort of what we do, and especially how it's different from firmware, is that software really is running code that runs on most of like your regular computers, I guess you could say, and really is focusing on like the autonomy aspect of robotics and dealing with like computer vision, motion planning, decision making, really like all your buzzwords right there, and does a little bit of like motion control aspects, but you can also see that in some of the firmware work people are doing. And what you learn mainly in software training is some basic C++ things, because you're mainly going to be working with higher level software, and ROS, which is the robot operating system, which is basically a framework that you're able to like visualize your robot in and send commands to your robot, and then a lot of concepts about autonomy for robotics. If there's no questions on that, then we're just going to move into like logistics of how training is going to work, especially since it's virtual. Were there any questions about any of that information? I'm going to take that as a note. So logistics, especially with virtual training, how's this going to work? So basically, sort of like I said earlier, we have 2 sessions a week. One is on Monday, one is on Thursday. They are both the same session because we realize that you guys have busy schedules and we don't expect that you're all available on one day. So you really only need to come to one a week. It's going to be the same content, and it's going to be from 6:30 to 8:30. And all meetings are going to be virtual on Microsoft Teams like this one. And so I talked a little bit, I hinted more at like how we're having electrical and firmware training organized, but here's more of like a table view of it. So like you can see, I mentioned a lot of the topics we're covering, and that's pretty much shared for the first 2 weeks of both trainings. And then we're going to split off at our second week, or third week, technically, where electrical training is going to focus more on Eagle and doing hardware design, and then firmware is going to be focused more on programming embedded systems, basically writing software for the hardware that electrical is making. And then we're going to join back at weeks 5 and 6. So that means basically for you, this week and next week, there's going to be one call, regardless if you're in electrical or if you're in firmware training, you're going to be joining this call. And then effectively at the end of week 1, we're probably going to send out some Google form seeing, are you interested in electrical, are you interested in firmware, just so we can get an idea of numbers. And then those weeks 2 through 4 that you're seeing on this chart, then we're going to have 2 separate calls where people who are interested more in electrical will talk about these like concepts about hardware and Eagle, and then people who are interested in like the programming and like low-level software aspect will join the firmware training call. And then after those things, we'll cover 2 weeks that sort of integrate both of those things together. Because really they're both two sides of the same coin. And so a lot of the content that is important for one is also important for the other. So just to go back to like sort of the online platforms we're using, especially because we sort of had to adjust this for this year. So we're using Microsoft Teams, and this is going to be for training calls. We might continue using this events feature, we might not, but we're going to have either this or just going to be a call on the channel. And then when we usually do some sort of lab or activity at the end, and that'll probably just be a simple call, which we can interact more with on like a face-by-face and like audio basis. And all of these are hopefully going to be, all of these are being recorded, and hopefully we're going to get them up on YouTube by this weekend in case you like miss a session or want to look back at something. We do have a Piazza. We put this in our first email, and that's a great place for you to just do Q&A. Like we know we have training help desk, but if you have a more, especially technical question, please put it on Piazza and all of us will try to respond to it. And then we also have email, and this is probably just mainly for announcements. We're going to be sending one each week, probably recapping what we did in the last week and telling you what you might need for the next week, if you need to like download any software or just like what we're going to be doing. And then on GitHub, we're going to be posting slides and labs, basically any document you see will hopefully be on our GitHub, and I believe there's a link to that in our last email, and if somehow you didn't get the last email, I will make sure to put all these links again in the one that we send out this weekend. And then Slack. So most of you are probably already on Slack, but basically this is going to be pretty much all of RoboJacket's team communication. So all of our text chat within like talking to your team members and all those different stuff is going to remain on Slack. So that a little bit about Slack culture or what Slack channels you should join. If you haven't already gotten that in your team meetings, basically you should be joining your team channel and then your electrical specific team channel. So for example, RoboCup and RoboCup Electrical. Some other channels you might not have been aware of before are Electrical Core, and this is mainly for collaboration things, and we do have like a collaboration meeting every 2 weeks where different members of the team come and meet and talk about what they're doing. Electrical AMA, and this is mainly just for like if you have any questions about something electrical or firmware related, that can go in there. And then Pixie Wranglers is mainly for memes and funny electrical things. And other than that, on Slack, please definitely set a profile picture and then what I do. So like, for example, mine probably says like RoboCup Electrical and has a picture of me. And that really just helps us identify you, get to know you better because we aren't like meeting in person nowadays. And then if you haven't noticed already, there's a lot of channels on Slack. There are some default ones, but you can definitely like go and like add yourself to other ones. So nice fun ones are RJ Girl Gang, Pets, which is one of my favorite because people post cute dog and cat pictures. Research is good if you want to start trying to get involved with undergrad research at Tech. And then Meet and Greet, which is a really nice way to meet other members of RoboJackets, as it like randomly pairs you with other people in the channel. You guys can do like a virtual like meet and greet. So with that, I'm just gonna like briefly introduce teams. I know you've probably already gone through this at GI and you're probably already on a team. But just to give a more, I guess, electrical focused view of this. So first we have RoboNav. You can see that there's the robot Jessie here, and there's a CAD picture of the electronics tray, and here is their main control board for the robot Jessie. And so I think the important highlights of RoboNav is that they do have like weatherproof electronics. So Jessie navigates through a field, and occasionally, not just occasionally, it always rains at competition. So the electronics have to be able to withstand that, and that's why you have like a nice case and all these things. And multi-threaded firmware is also very important. Next we have RoboCup, and this is autonomous 6v6 soccer. And they focused a lot on power electronics because they have a high voltage board called Kicker that's able to kick the ball they have. and they do FPGA-based motor control. So if you're on RoboCup, you'll definitely learn a lot more about that. You can see a nice picture, overhead picture of the robot here, with this just showing off their control board and like a custom microcontroller that they've made. Next we have RoboRacing. So the pictures here are Sidani and Rigatoni. They're two robots. And this is a picture of a PCB they've done, which is PoE, just power over Ethernet. So they work on distributed network systems. So Rigatoni is really connected through Ethernet, and then high speed and power, because Rigatoni is fast, or is supposed to be hopefully soon, and power, especially because Rigatoni is probably one of our largest robots. Next we have Robo Wrestling. So that's real-time strategy, small packaging. If you see one of the robots, Gucci and Kirby here, they're quite small. And this is one of the control boards, and they have to be able to move at like very high speed at like a very short amount of time. So yeah. If there's no questions about any of the teams, I'm just going to do a brief thing about like generalization of like what robotics is. Assuming that there's no questions, I guess we'll just get into what is a robot. So you can see a nice little graph here. So basically, a robot is just interacting with its environment, and it's performing actions through like actuators. And these actuators can be anything from like a motor, a servo. And then from its environment, it's taking in all this information through sensors. So that can be like cameras, can be a LiDAR. And using this information, it's able to make decisions, which then can affect its next actions. So a good example of this, we're just going to look at a small case study, is with Jessie. So you can see a nice picture of Jessie here, and you can see sort of like a breakdown of what Jessie looks like. So you can see the mast, which has most of actually all of the sensors, the electronics tray, which has a lot of the custom electronics, and then the chassis that has the drive motors that move Jessie around on the competition field. So sort of relating Jessie back to that earlier flow diagram we had. So Jessie has a lot of sensors. Those include a LiDAR, IMU, cameras, and encoders for reels. And these are some things you'll probably definitely learn more about on your teams, about what each of these do. And so it takes all that sensor information, and then it's able to make a decision. And it processes this using there's a custom computer on board, and there's also a embedded microcontroller that's able to take all this sensor information and then send commands. And those commands are sent to the actuators, which in Jessie's case is just 2 brush DC motors. So if nobody has any questions on that, I will go into electricity basics, because that's what we're working with. So a lot of this knowledge is a lot of things you're definitely going to learn in Physics 2, and then a little bit of what you might learn in like ECE 2040. So if you haven't learned that, we're going to try to give you a review, and there's also going to be a document posted on GitHub, which goes a little bit more into the information I'm going to be talking about more in depth. So if you're confused on any parts of what I start to say, of course, ask questions, and then definitely read that document later after the presentation, and things might make a lot more sense because it's explained in a lot more detail. But basically, to start off, what is electricity? So electricity is just the movement of charged particles. Basically, it's these charged particles are moving in response to voltage from like a high to like a low potential. And the best way to another way to look at it, because that was like a very abstract way of explaining it, is to look at analogy with water. And so you can think of water as the electrons here. So in the first picture on the left, you can see a description of what voltage is. So this is just voltage is basically just like the pressure behind the water in this example. So as the tank rises, there's more pressure, and that represents the voltage. And then you have amperage, or really current here, and that's the amount of water that's flowing. So you can see with the bigger pipe at the end, more water is able to flow. And basically this is just representing the amount of charged particles that flow. And then on the right you have resistance, and this is what prevents, like essentially in this case, the water from flowing, or with electricity case, what prevents electrons from flowing. So you can see with the pipe that has like a little like kink in it, that means more resistance because less water is able to flow through. And so all these three principles sort of tie back into a very important law, which you may have heard of, which is Ohm's law, which basically means that I equals V over R, or if you may, or also like V equals IR is more common, I think. And basically this breaks down into current, voltage, and resistance. So current, again, the net flow of charged particles. We sort of talked about with the water analogy, which is measured in amps. Voltage is that electric field potential difference measured in volts. And then resistance is the difficulty for a current to pass through, or sort of what we saw with like the smaller, the pipe with the kink early in the last slide. So this is a law that's going to come up in a lot of like circuits classes and sort of is the basis for a lot of circuit things that we do. And then here's like an example circuit that sort of can tie in those concepts. So with the picture here, you can see a battery connected to a light bulb, and then we have a switch here that is controlling that circuit on and off, so you're able to change if the light bulb is on or off. So you can see that the battery here with the positive and negative end is just creating a potential difference, which can push electrons through the circuit, and which is how the LED is able to turn on. And in the bottom diagram here, you can see the flow of electrons. And also just by convention, the current flows in like the opposite direction of what we say the electron flow is. And this sort of, again, ties back to a tool that we use very often, which is a multimeter. So a multimeter is able to measure the DC voltage, the resistance, the current, and then a new topic, which is continuity, which basically measures is there a connection between these 2 points. And if there is, there's like usually a very like low resistance between those 2 points. So now we're going to go into like various electrical components. And so this is something that you're going to find on PCBs. This is going to be something that you've maybe prototyped with, and you'll definitely use a lot throughout your time if you're doing hardware design, and you'll definitely come across if you're doing anything with firmware. So resistors, like the name, are just adding resistance into your circuit. And so we mainly use that to reduce current flow, which you can definitely see with that water analogy, and then divide voltage, which we'll sort of explain in a later slide. And then capacitors are mainly stores energy as like charge, and they're usually used to like smooth voltage levels as they're able to like store this charge, and then it dissipates. Next we have diodes. So diodes mainly just conduct current primarily in one direction, and they can be used as like a protection type aspect, or like if you only want current to flow in one direction of your circuit, that's what you use a diode for. And a really common one is what we call LED, a light emitting diode, and basically it gives off that energy as light, and it can shine brightly. Fuses are basically there to prevent overcurrent, and basically it'll essentially blow if a device is drawing too much current, and this is commonly used in power circuitry to protect your components. And next we have transistors. So transistors can act as electronic switches, and can amplify electrical signals, and they are definitely more explained in the document that we're going to have on GitHub if you want to learn more about how they actually work. But basically, main time we use them is that so one device can really just control power going to another, and you'll definitely learn about these in really great detail in some of the higher level EC classes if you take them. So good to get back to some of the earlier things when we talked about resistors. So two common circuits that we have are parallel and series circuits. So first, parallel, basically there's a constant voltage drop for each path. So you can see with the circuit below, you have the battery here, and then you have 3 resistors effectively in parallel. And basically, the voltage that's going across resistor R1, R2, and R3 are the same. And then on the other hand, you have series circuits. So that's when current is the same everywhere in the circuit. And so when I mean series, it basically means that all the resistors are connected one after another, like so. And basically the current going through resistor R1, R2, and R3 are all the same, but not the voltage. So this basically can be summarized down to like these couple of formulas. So basically with parallel circuits, since the voltage drop across each resistor is the same, this basically means that the total voltage in the battery is the same as the voltage drop across the resistor 1, 2, and 3. And that can be related to also the total resistance, which is shown with the formula here, where basically 1 over our total is equal to the sum of like 1 over R1, 1 over R2, 1 over R3. And then looking at series, basically the voltage drop across each resistor adds up to the total voltage, which is in the battery. And then with it being in series, you can your resistance total is just the sum of all the resistor values you have. So common terms that you may also hear us talking about. So VCC and VDD, this is really just referring to like your power source. And then ground is, or GND is what we say. And this is basically just a reference voltage for 0 volts. I believe that is the end of the presentation. So if there are any questions, you can ask in the chat now about anything that I just said. Otherwise, I will probably end this event, and then we're going to start a call in the, actually, Maureen, how many current attendees do we have right now? Or anyone?
17.
Okay.
Joe was faster.
Yeah, I think that,
Let's just do the one breakout room.
yeah, I agree. Let's just do the one breakout room. So basically, if no one has any questions now, and you can also ask questions when we're in that room, but basically what we're going to do is end this call, and then we're going to start a call on the electrical channel. So you see, if you go back to your MS Teams, you'll see next to electrical training, there'll be like a little camera thing that'll show. And that means we'll start a call, and then you'll be able to join that, and that'll give you access to like, you turn on your camera and like talk to us with your like mic and stuff. And of course, like also just ask questions. And then in there, we're probably just gonna do like a quick Kahoot over some of the stuff we talked about and like get to know you guys better.